Alright guys, we're going to be identifying linear functions today. So, linear function. It's a function whose graph forms a straight line. That's why it's called line R, linear. So it's just a function that when you graph it in the calculator or you graph it by hand, like most of your projects that you've done, it forms a straight line. So there's three ways to identify linear functions. One way is by the graph. The second way is using the domain and range. The third way is by the equation itself. Let's look at each one of these individually. Alright, so let's do graphing first. Now this is obvious. We're looking for the graph that shows a line because we're studying linear functions, line functions. So this one is good. This one is not a line. And this one's not a line. These are different functions. So like with different powers and different things like that, different relationships with their x and y's, they're not considered linear. Now the parent function for linear is y equals x. That's basically before we add or multiply or subtract or divide anything to these variables. So, and it goes right through the origin. So actually, it looks more like this. Goes right through the 0, 0 and goes up 1 over 1, up 1 over 1. But we'll talk more about that later. How you identify by just looking at the graph is if it forms a straight line. If it curves like this one or curves like this one, it's not linear. Second, we can do it by the domain and range. The easiest way to do it by domain and range is if you table it. So put it in a table and then we look at them. So now that it's on a table, what we'll do is we'll see the connection between the domains and the ranges. So on x side, how is it changing every time? That's what we want to focus on. Well, from -2 to 1, -1, it's plus 1. From -1 to 0, plus 1. 0 to 1, plus 1. And 1 to 2, plus 1. It changes the same every time. Now let's check out the other side. 7 to 4 is -3. 4 to 1, -3. 1 to -2, -3. And -2 to -5, -3. Since all of these change, and all of these change at the same rate, then this is considered a linear function. Now let's do some more examples. Here's an example. Now this one's not written in a table format, so you want to do that just to make sure. So let me make a little table. So now you see that I put it in a table, and this is how I did it, just in case you don't know. The first values in each one of these is the x, because x is always before y, just like in the alphabet. And then the y's are the green. Alright, so we're going to look at the trend between each one. The x's have a +3 trend every time. And the y's have a +1 trend every time. Since they're all doing the same rate, since these are at the same rate and these are at the same rate, then it is linear. So let's do this bottom one. Now I have it where I have it in a table. So I'm going to see how x changes. It gets +5 every time. So far so good. Now we look at the y's. We have -6, -2, and -2. Now these are at the same rate, so it's good, but then these are not at the same rate because of the 6. So this is not a linear function because of that reason. All right, linear equations. What a linear equation is any equation that can be written in the form a times x plus b times y equals c, where a, b, and c are real numbers. So they're just numbers like 2 or 3 or 4 or even a half or 3/4 or anything like that. They're just numbers. Now, one thing you have to remember is that a and b are not 0. I mean, now a can be 0 and b can be 0, but not both at the same time. All right, so let me show you why. If we had if a was 0 and b was 0, that's a horrible plus sign, and b was 0, then what would happen would be that c would end up being 0 too, because 0 times x is 0, plus 0 times y, which is 0, would have to equal 0. So basically it zeroes out our whole equation. And that's why it says this. You'll never actually have that happen, but they have to put it in there because somebody somewhere will throw a fit if they don't. So anyway, what this is called, when you have an equation in this form right here, this is called standard form. So when I ask you to put it in the standard form, that's what I'm talking about. So to tell if an equation is linear or not, you have to put it in standard form first. So here's an equation and it's not in standard form. So we have to get it in standard form. So we want to solve where x and y are on the same side and the negative 2 is on the other side. Just like this right here. It says ax plus by equals c. So let me show you. I want to put my y on the other side, and the reason why is because I'll have both my x and y on the same side. So I'm going to subtract y on both sides, and I would get negative 2 equals 3x minus y. Now I can rearrange this now that I have an equal sign. This is the same thing as saying 3x minus y equals negative 2. I just put it in the backwards order. Now, does it look like our standard form? Ax plus by? Yeah. It does look like that. In fact, in this case, a would be 3, b would be negative 1, and c would be negative 2. So we did figure that out. So this is a linear equation. Let's try another one. Here's another one. 3xy plus x equals 1. So let's see if we can put it in the form x or ax plus by equals c. Well, we have our x's and y's already on one side. And the only way that I can get rid of this x from the 3y would be if I divided everything by x. And let's see what happens when I do that. I would have to divide everything by it. And I would get 3y plus 1 equals 1 over x, which is totally crazy. That's actually called the reciprocal function. And we'll talk more about that probably in Algebra 2 or maybe even later this year. But Algebra 2 is basically where you're going to be handling this. And you can already tell it cannot be written in the standard form because the x's and y kind of screw each other up. So let's look at this bottom one. Can this be written in ax plus by equals c form? No, because the reason why is because you have a power. X squared. There's no way we can get rid of that x squared unless we divide it by x. and you would get x is equal to y over x, which doesn't make sense at all. That's even more difficult than it was. This one's actually considered a quadratic function, so you should already know that that's not linear. It makes a U-shape. All right, a couple more. Can this one be written an ax plus by equals c? Well, the first thing I'm going to look at based on the last two questions is, are the variables multiplied together? No, they're not. Do they have a different power? No, they don't. So we're good. So now let's keep on working. Let's see if we can solve it. I've got to get my x and my y's on the same side. So I can subtract 5x, and I would have gotten negative 5x minus y equals 0. Now this is in this form because a equals negative 5, b equals negative 1, and c equals 0. Pretty easy, huh? Let's try a different one. This one, you can already tell we're going to have complications, and the reason why is because y is in the denominator spot. This does not have y in the denominator spot. It's being multiplied. So because we're dividing by that y, it's going to change everything. So this is not a linear function. What about y equals 2? Well, we can write it as ax plus by is equal to c. And the reason why is because on this particular one we can say that a is 0 times x, b is 1 times y, and c is 2. So yes, we can write it in that form. Remember, the only rule is that a and b can't both be 0 at the same time. Now this one down here is a little tricky because it's like saying 1x plus 0y equals 4. The only problem with this is that it's not a function. Because remember, functions have to have exactly one y for every x. And this x is always 4. And that means no matter what the y value is, 100, 1,000, or whatever, 4 is for x, and it's going to be mapped to all those other numbers, an infinite amount of numbers. So this is not even a function. In fact, if we graphed it, it would look like this. 1, 2, 3, 4. That's what the graph would look like. It's a vertical line. In fact, it completely fails a vertical line test. All right, if this seems confusing, we'll work on it in class. So that's it, folks.